So I just want to take a couple minutes here to go over the homework here for the nuclear decay problems. And if you're having issues with this after this, I do suggest you come in and get some extra help. So looking at number 1 here, this is my divider line. What you have to keep in mind here is this coefficient. You need to multiply that by both the mass and the charge. So this actually turns into 142 plus 91 plus 3 at the top. So that makes this equation at top, you should have the number 235. And on the bottom, 3 times 0 is still 0. So 56 plus 36 would balance out on this side with a 92. We then use our periodic table to look up element number 92 based on that bottom number, and that would be U for uranium. All right, with number 2, divider is here. 37 is equal to 0 plus 37 on the top. And then 19 is equal to 1 plus 18 on the bottom, and 18 is AR. With number 3, okay, 4 plus our 208 gives us 212 on the top, and then 2 plus 81 gives us 83 on the bottom, which is BI on the periodic table. Number 4, 239 is equal to 4 plus 235. And then 94 equals 2 plus 92, and again that is uranium. Number 5, 9 plus 1 is equal to 4 plus 6. That makes it 10 equal to 10. And then 4 plus the 1 is equal to 2 plus 3. Once I have those numbers, look that up, and that is Li. All right, let me slide this down so we can do 6 through 10. Here we go. All right, with number 6, again we have to keep in mind that we have one of these coefficients. So that actually changes this to a 2 on top and a 0 on the bottom when we are balancing. So when I do that math, that turns this into a number 97 up on top with a 40 on the bottom, which is ZR. Number 7, I end up with a 99 on top. Be careful here with that negative. That means it's a 44 on the bottom, which is RU. Number 8, I have 242 on top and a 94 on the bottom, PU. With number 9, when I do the math, I end up with a 1 on top and a 0 on the bottom. Now this is one where I can't use my periodic table because we don't have an atomic number of 0. This is actually off of some of the information from your notes. If you find the one that matches, that's actually a lowercase n because that's a neutron. In number 10, we end up with almost the exact same thing. Actually, the exact same thing. So don't forget that you can actually use your proton, your neutron, and your electron as well. Okay, so you've got your particles of radiation like your alpha particles, all right, or your beta particles or your positrons, but you also have these other items that could fill in for the nuclear equations.